The US Forest Service spends half of its entire budget fighting wildfires. A study into the fires of 2018 put the economic cost of just those in California alone at $147 billion. But these firefighters are about to benefit from a revolution that is happening hundreds of miles above them. In recent years, satellites have been getting smaller, smarter, and cheaper. Often referred to as nanosatellites, they have opened up the space industry to a new generation of companies and scientists who are in turn revolutionizing our ability to observe our planet and to communicate. In Munich, Germany can be found Aurora Tech, one of this new breed of space technology companies enabled by the advent of these nanosatellites.
We plan to use a constellation of about 100 of such satellites to watch for wildfires, anything larger than 10 meters across. It's part of the world's first global wildfire intelligence service, and we will be able to detect fires and report on the outbreaks within about half an hour.
Aurora Tech's system is based on years of research at the Technical University of Munich. Fitted with thermal infrared sensors, the satellites will be able to reduce wildfire detection time from hours down to minutes, and then be able to monitor them in real time, transforming not only our ability to fight them, but also our understanding of their causes.
The reason why we're able to do it right now, and we wouldn't have been 10 years ago, is because of the improvement in technology driven by the computer and smartphone industry, but also the sensor technology we are using. This has become available within the last couple of years. This new technology has kind of opened up the space industry, not just to startups like us, but also to research groups at universities, to students, to test new technology in space.
Helping to nurture this new global space industry are organizations such as Satellite Applications Catapult, a UK government-supported space innovation company which provides advice and shared testing and operational facilities.
Right now, we're seeing space pivot from where it was previously about a little bit of trying to outdo your international neighbor in terms of military capability in defense and aerospace, or understand our cosmic origins of the universe. We're pivoting to commercial space. So we go to space now to basically create an economy, to create material wealth, which we can use on Earth and we can use in space. So what's happening right now is that we're seeing companies from across the world saying, space, this is the place we need to be. This is the place we need to do things.
And at the heart of this revolution are nanosatellites. A fraction of the cost of what has gone before, their roles can be many and varied.
It might be looking at the weather. It might be looking at climate change. It could be a new type of communication. It could be listening for identification signals from vessels at sea. There's a whole host of opportunities looking down, but increasingly also looking up.
But whatever their role, they need to be able to withstand the rigors of spaceflight. Here, for example, the resonant frequency of a potential satellite component is being tested. Incredibly, these vibrations are initiating a force on some parts of the structure of up to 75 G, which is more than 25 times the force experienced in a standard rocket launch. The ability to access shared facilities such as these here at Catapult is playing a crucial role in developing new talent and expertise. The seeds for this new space industry were in many ways first sown back in the late 1990s, when California Polytechnic State University and Stanford University developed the CubeSat. Based on a 10-centimeter cube and able to be scaled up if needed, it provided a standardized specification that could accommodate off-the-shelf parts. Suddenly, a satellite was something that could be built cheaply and quickly. It was a total game changer. And it's the same specification that's being used today. In Finland, astronomer and journalist Jari Mäkinen has taken this technological accessibility a stage further.
CubeSat is fully functional one-unit CubeSat. So just like many satellites that are going around Earth now on orbit, but it has been made with the parts that are not so expensive as are the parts for the real satellite.
Although not destined for space, this educational tool gives students the ability to not only build a satellite, but also to operate it in a very similar way to its space-going counterparts.
And the most exciting thing is flying it to stratosphere. You are launching it to the edge of space on a stratospheric balloon and fly it up to the 30 kilometers or more. You get telemetry down from the satellite. You can chase the payload when it is flying, and of course planning the mission. Basically, after this, you can go right away to build a real satellite or operate the satellite that is really in orbit.
Which is exactly what Jari and his colleagues at Arctic Astronautics and Finnish technology company HALD are now doing, with an extraordinary experimental mission, the launch of the world's first wooden satellite.
This is basic research. This is material science mission, just to see if wood could be used as a material for spacecraft.
The project is known as Visa Woodsat, and it's secured investment from UPM, a leading plywood manufacturer based in Finland, as well as assistance from the European Space Agency. One of the potential benefits of using plywood panels is that they don't interfere with certain sensitive monitoring equipment. And in an industry where weight is a major factor in launch costs, its plywood construction means that the Visa Woodsat will weigh less than 1 kilogram, making it one of the lightest CubeSats ever launched.
We are using plywood that has been in a thermal vacuum, meaning that it has been in a temperature of 102 degrees for a couple of days, and at the same time in a vacuum. So it is extremely, extremely dry plywood after that.
The wooden panels are also coated in a 100 nanometer protective layer of aluminium oxide, normally used on electronic circuit boards.
It is something, again, that nobody has been thinking before, but according to the tests that has been now conducted at ESTEC, at the Technology Center of European Space Agency in Netherlands, they have tested this kind of plywood, and it seems that it is even better than most of carbon fiber or glass fiber that is used actually right now in space applications. I do have here one copy of the satellite. So this is almost final design. And with this little camera, we can then take pictures of the satellite. And in fact, inside over there, we have another camera as well that is taking pictures from the inside of the satellite.
The satellite will also house sensors to detect any moisture that could be released by the plywood once in space. Using their experience from CubeSat, a prototype has already been tested using a stratospheric balloon.
Many of the traditional space engineers said originally that you are crazy, this is nothing, are now getting a little bit more interested in this. After all the results we have now got from ESA and all the research that we have done ourselves as well, this really may be interesting stuff in the future.
What makes nano satellites so powerful is their ability to work together in groups, known as constellations. But projected numbers of satellites are becoming so large that these new groups are often referred to as swarms.